the first tanks rolled onto the battlefields of WWI, their primary purpose wasn't to destroy, it was to survive. The British Mark IV's 12mm armor wasn't designed for offensive dominance, but to protect crews from machine gun fire. This established a fundamental truth. A tank's effectiveness is measured not by its firepower alone, but by its ability to remain operational under enemy attacks. Modern militaries now quantify this as survivability, the sum of protection, mobility, and redundancy that keeps a tank fighting. The interwar period revealed a harsh lesson. Tracks were the weakest link in survivability. French Renault FT tanks in the 1920s frequently lost mobility when their narrow tracks snapped or clogged with mud, making them sitting ducks for artillery. German engineers documented that 63% of tank losses stemmed from track failures rather than direct penetrations. This forced designers to rethink track systems not as mere mobility tools, but as critical survival components requiring redundancy and quick repair features. World War II's Eastern Front became the proving ground for track survivability. The Soviet T-34's wide, all-steel tracks with snow grousers maintained mobility in -40°C winters where German tanks froze solid. American tests showed that the M4 Sherman's rubber-bushed tracks lasted 3 times longer than previous designs. Modern composite rubber-metal tracks now incorporate Kevlar layers to resist mine blasts, a direct response to Iraq War data showing 40% of mobility kills came from IEDs targeting tracks. Contemporary tanks like Israel's Merkava 4 demonstrate how tracks integrate with overall survivability. Their tracks are designed to detach cleanly during mine explosions, channeling blast energy away from the hull. Thermal imaging reveals how modern track skirts regulate heat signatures, making tanks harder to target. The U.S. Army's TACOM reports show Abrams tanks with upgraded T-158 tracks achieve 92% mission continuity rates in urban combat, proving that mobility preservation equals combat persistence. Emerging technologies are taking track survivability to new frontiers. BAE Systems' adaptive tracks can change rigidity instantaneously, soft for mud, rigid for roads. Rheinmetall's AI-powered track health monitoring predicts failures before they occur, reducing maintenance casualties by 75% in trials. These innovations confirm that after a century of development, the central truth remains. Tracks aren't about movement. They're about maintaining the tank's lifeline to survive another battle.